Okay, hi guys. So let's continue on how to solve example 8.1. So the question asks you to determine the maximum ground level concentration of sulfur dioxide only. Okay. So you from this total coal, so you need to calculate how much of sulfur dioxide, right? So the question want you to determine the maximum ground level concentration, which is C. Okay, and the distance from the stack at which occurs. So you need to know, this is the keyword, maximum ground level concentration. So earlier we know that we use this formula, sigma z is equals to 0.707 H for maximum ground level concentration. Okay. So first we solve for this one. Okay, we need to determine the sigma z. Here the height of the stack is given, right? In the question. Okay, is it given? Yes, it's given in the question, which is this is the H 75. So your sigma z will be 0.707 times 75 meter, which will give you around 53 meter, right? 53 meter. So you want to determine the C. Okay, so based on equation 8.4, okay, equation 8.4 for determining CXO, okay, at ground level, maximum ground level concentration. That's why we use this equation, right? So Q pi u sigma z sigma y, and then exponential minus h over sigma z, right? So you've already determined sigma z and also you have h. So now say you have your u, so you need to determine sigma y. Okay, how to determine sigma y? Okay, first you have sigma z, so you determine x, okay, from the graph. Okay, so now the keywords here, they use atmospheric condition. Okay, this is the atmospheric condition to decide whether class A, B, C or D, okay, are moderately to slightly unstable. In this book, they choose it to be on class C. Okay, so class C. So you refer back later. Okay, in this. Okay, so this class C. So it's similar with what I have done earlier. So for this example 8.1, the sigma z earlier was given around 53. Okay, just now I explained when you have x, then you try to find also. Sorry, this is z. When you have x, then you find your sigma z. But this time around, you have your sigma z first. Okay, and then you determine your x here. So your sigma z in example 8.1 is 53. Yeah. Okay, if you see here, 53, this is 5, so somewhere it is 6, right? So it's somewhere, maybe somewhere here. So later you need to be very specific on this. So 53, and then you go to C. So later it will somewhere at 800. Okay, this is 8, this is 9. So it's in between 8 and 9. So around 850. Okay, from the example 8.1 is 850. Okay, so 850 meter, right? So you get that x value 850, and then you try to find your sigma y in this graph. So 850 again, just now this is 5 6 7 8 5, so maybe somewhere, so you go to line C. Okay, so 8 probably somewhere here. Okay, right? So right, okay, hold on. So maybe it's around 88. In the book is 88. So you can see there is 8, there is 90, there is 100. So more or less is that figure lah. Right? So when you get that, okay. So here you get x is around is 850 meter, and then you go and find for sigma y, which is when you get from the graph, it will be 88 just now, right? 88 meter, more or less. So this 2 is from graph. Okay, graph figure, what figure is this now? Figure 8.10, 8.11. 8, 10, and 8, 11, right? So once you determine that, okay, so now you can solve this because you have Q, you have your U, sigma Z, sigma Y, H is given 75, sigma Z also is given. So that's why you will get 531 microgram per meter square. All right. So you must make sure that you have all the same unit so that it will be cancelled out this part. Okay, and then this is all in meter. Okay, Q is in gram. Okay, so for how to calculate Q, it's only based on the sulfur. That's why earlier, if you see in example 8.1, you see how they calculate for sulfur dioxide. Okay, so sulfur is 32, oxygen is 16. Okay, but it's 1 to 1, so 1 sulfur, 1 S, and 1 oxygen. Okay, so you look back there. Okay, I think it's a simple example for you to understand, right? Okay, now let's go to example 8.2. Okay, let's continue on example 8.2. Okay, so this time around is a continuation for example 8.1, but they want you to calculate the there's two things that you need to calculate. One is the ground level C concentration. Okay, at distance 3 kilometer. Okay, 3 kilometer. But they have at the center line. Okay, so you need to this 3 kilometer you need to divide by 2. Okay, and then that's why it will become equals to 1.5 kilometer. Okay, another one is to calculate the C, the concentration at ground level as well. Ground level, okay, ground level, but oh, not ground level, sorry, not ground level, sorry, but a crosswind distance, sorry, crosswind distance. Okay, distance of 0.4 km. Okay, so here the you need to calculate C30, okay, at center line. So that's why we can use this formula again, the formula that I used earlier in explaining example 8.1. Okay, so sigma Z, sigma Y, okay, and then exponential negative half H over sigma Z, right? Oops, 2 square. Right. So given to you the H is 75 because it's continuation from example 8.1. Okay, but you need to find a new value for sigma Z, sigma Y. Okay, because they change the distance already is 1.5 kilometer. So again, you refer to this graph. Okay, this graph again. So earlier it was earlier it was how x is 8.5. 850 meter. But this time around the x is actually 1.5 kilometers, so it's 1,500. Okay, so it will be somewhere here 1.5. Okay, so you choose C. So maybe, okay, if you look in the book, they give you sigma Z is actually sorry, Okay, sigma z is 170. Okay, 170 is actually somewhere here, right? Okay, so I think maybe the book still used at 3. So this is 3. So 1.7 is actually here. Okay, so the correct one is because they're asking at the center line of the plume. So giving you the distance is 3 kilometers. So at the center line is supposed to be x equals to 1.5. So that's why earlier I showed you this is 1.5. So you find your value. It will be around this value 90 or 80 something. Okay, but let's say because I want to stick to the example 8.2, but you know that the value is wrong already, right? Okay, so but I continued taking this value of sigma z as written in the example is 170, and sigma y they put sigma y as 280 meter. So it is class C. Again, I think they didn't take at 3 at 1.5, they took at 3. So let's see how whether my assumption here is correct or not. So 3, sorry. So 3 here, 2, 3. Okay, 3 C. So it will be somewhere there. So in your textbook, yep, this is 3, 4, 5. So it's around sigma y is around almost 3 to 180. By right, it's supposed to be the distance is 1.5 kilometers. So it's supposed to be here. Okay, it should be lower. But this book taking this at sigma y. Okay, but as long as you know how to find the sigma y and sigma z, it's okay. And then you insert in the equation just now. Okay, and then you solve. Okay, since you have all the value already, so you solve for that, and then you get 128 microgram per meter cube. Earlier, it's supposed to be 8.1 is supposed to be microgram per meter cube also, not meter square. Kalau meter square is wrong already. Okay, right. So it's concentration. You already know concentration is gram per is in per liter or per decimeter cube, right? And then for the second part of the example 8.2 was actually asking for distance 0.4 kilometer. So that's why it is a ground level. Okay, at 3 kilometer again, 0, it's not ground level, sorry, it's 3 kilometer distance, but it's 0.4. So that's why we put the coordinate like this. So you use the equation 8.3. Okay, I malas nak tulis, so use equation 8.3. Okay, so in there, alright, you have the H value. Okay, H value you have, and then you have the sigma z, sigma y. Okay, you know how to find for this. Okay, so and then what is the value of y? Y is actually 0.4, this value. So it's equals to 400 meters. So you insert all the equation, okay, and then that's why you have your C30.4 is actually 44.9 microgram per meter cube, right? Okay, so I think I stop here for example 8.1 and 8.2. Okay, see you in the next video. Bye.